In the diagram below, a light ray moves from surface 1 to surface 2 while the angle of incidence is gradually increased there. So they keep increasing the angle of incidence there. And let's see what happens there. You can see that it keeps bending. So it's bending away from the normal there. So you can see here it's bending away from the normal. So the more they increase the angle of incidence, it goes further away there. Until see there, this is the first part. This is when they increase the angle of incidence, and it bends further away. And then here at C, we can see that it's traveling on the boundary. The light ray is traveling on the surface of separation there between the two media, between the two media there. And the angle of refraction here is 90 degrees there. And then here we see the light ray is being reflected back. It goes back into surface 2 there. Okay. The questions 10.2.1 says, give the name of the phenomenon represented in diagram D. 10.2.1 there. This is what when this happens, when the light ray does not go into the other surface, but it is reflected back into the original surface, original medium. This is what we know to be total internal reflection. Total internal reflection when the angle of incidence is greater than the critical angle. This happens because the critical angle has been surpassed there. So when you go beyond, the angle of incidence goes beyond the critical angle, the light ray is reflected back into the original medium. And there's a definition for total internal reflection there. When the angle of incidence is greater than the critical angle and the light ray is reflected back into the original medium there. And staying a little bit there, the conditions for total internal reflection, if there was a question, is that the light ray must be from a more dense medium to a less dense medium there. And the angle of incidence, that's number one. Number two, the angle of incidence must be greater than the critical angle. That's condition number 2 there. And one should also know the applications of this phenomenon, telescope, periscope, endoscope there. So 10.2.2 says there, define the term critical angle. Critical angle is the angle of incidence. The angle of incidence in the denser medium. In the denser medium, when the angle of refraction is 90 degrees there. The angle of incidence in the denser medium when the angle of refraction is 90 degrees there. And this is what we see there on diagram C there. Which angle in diagram C is the critical angle there? The angle of incidence that gives us that angle of refraction of 90 degrees, I3, that angle of incidence there. That is our critical angle there. So it's a simple 4 there for this one. Okay.